I would like to know if weather is good at one day together that we took pictures of the moon
Oh yes.
with a
Parallax.
with a vertical reference a vertical reference on it to be able to measure the angle, the tilting of the moon, and compare it with our locations.
Yeah. That'd be
You
lovely.
mean the orientation?
The orientation, yes.
Right.
Yeah, we need to do that. Both looking east or both looking west, though.
Yes, but I'm not really on the same longitude as you. So that is where is my GPS?
I think
GPS.
everybody should have a Theodolite,
Yes, I agree.
including me.
Yeah.
I'm 121 longitude.
We're 151, so yeah, we can still do that. I'll get it a bit higher in the sky.
We're on 151.
Yeah, I think so. I think.
East.
Are you in the middle of the ocean?
No, Sydney.
All right, we are
151.
live.
151 east. East.
Still. Okay. That sounds wrong.
No, 151.
Yeah, because I did it already with some other Australian, Trouble, Emperor of Australia, and Jimbo, but we didn't have any vertical reference. But I think if we have our vertical reference, perhaps even without the azimuth of it, we should be able to calculate the distance between us.
Yeah, I can get a vertical angle. Azimuth is a bit trickier.
Yeah, azimuth is a bit trickier. But a vertical under, just with a picture, with a vertical reference, we should be able to get an angle that will be perhaps at 1 degree, 1 degree or less than 1 degree good. It should put us at approximately the distance between us.
Yep. Whereabouts in China are you?
I'm in Nantong, next to Shanghai.
Okay.
Since when
Not too
the
bad.
word 100 isn't used anymore? So I thought
What?
you meant 1 degree and 51 minutes.
Oh, sorry.
That makes sense.
151.
Okay,
Yeah.
yeah. I just went to Sydney and then that made sense.
Yep. Nice. Nantong, there it is. All right.
So
On the river.
Yes,
Very good.
we'll stop babbling and let you go with your presentation. What you want to talk about?
Muting.
No, I think we're just here hanging out unless Jesse has more stuff he wants to go over just to test. They got pretty crazy in there though.
I'm of the opinion they're all lying now, basically. I used to treat them with good faith, and now it's, Alan in particular. So.
I think if we could, I'm going to say get rid of, but I don't mean get rid of them entirely. But if we could
take care of them
without a few of the vocal ones, I think it would go a lot better.
Yeah. Like that guy, J-Rod, the one that give me 5 minutes, please. He's just cheerleading for them. Like, he has no idea about it.
Oh, that was funny. He tells me I'm wrong. So I asked him, well, here's the numbers. Which one of these is wrong? He's like, says he doesn't know anything about any of the numbers.
Yeah. It's pretty embarrassing.
Well,
I have a
I
hankering
guess I
for
could...
some chocolate. I'll be back in a sec.
Okay, when he gets back, I'll go real quick over my little presentation. And then if anyone has questions, they can ask them.
Just what we are looking at, because I saw on the top a warning, work in progress, expect error, contact Jess.
Try that again. I'm slow of hearing.
Okay. On your present, on what we see on the screen, when we see an Excel sheet, and there is work in progress, expect errors, contact Jess, and something. It is your spreadsheet or is with question? Okay.
Yes, it's well, I took their spreadsheet and copied it to my Google account, and then I got rid of all because they've got like all this extra stuff up here in the middle, and lots of stuff that doesn't need to be there. So I made it nice and simple using their same data set. I used their same math for the flat Earth prediction, and the correct globe method for the globe celestial theodolite to compare it, and then a little thing that shows which one wins, which one's closer. I could probably actually get rid of this work in progress line. I put it on there in the beginning, just in case someone saw it and saw an error and knew to tell me, but no one's...
But just you put globe wins by 18 meter, but you put the error of flat Earth is plus 30 meter and the error of globe Earth is minus 12 meter. The delta between these two data is 42 meter, not 18 meter. What?
Well, that's how much closer the globe is to the zero mark than the flat Earth method is.
Okay, so the globe win by being 18 meter closer to the whichever prediction.
To the results of the celestial theodolite, to the timing, to the expected timing occlusion angle.
Okay. So the globe is 12 meter to the prediction, but it is 18 meter better at predict than the flat Earth.
Yep, because the flat Earth error was 30 meters in this case.
If we put that in another way, if we put that the error of globe Earth is 100%, the error of flat Earth is 270%, something like that.
I think I'm getting hungry. I thought I heard you say croissants.
No. I said percent.
Persons?
Oh,
Percent?
he's French. Half of what he says sounds like croissant. I'm just kidding.
And we don't say croissant. When you know how to speak, you said croissant.
Croissant?
Croissant, yeah.
Well, anyway,
Croissant.
it's making me hungry.
Yeah, just the comparison that makes that the globe is if you make 30 over 12, 12 over 30, well, not 30 over 12. Wait. Just makes that globe is the 2.7 times more accurate than the flat Earth.
Oh, like a ratio or something.
Yes.
Okay. I'll think about that. But I gotta keep it simple. And most people recognize that 12 is a smaller number than 18. And that's the way they're staging it. So
I did a root mean square.
Oh yeah?
Away from 0. Yeah. Which where is it? Hold on. Where's my spreadsheet? Did I close it? There it is.
By the way, if you have anything you would like to present related to this, I will step down and you may present.
Oh, no, completely unprepared.
Oh, okay.
Oh, is this like a live stream?
It is. We are live streaming on my no-name YouTube channel with one video, and that's this one, and no
Nice.
subscribers.
I'll stick it in the chat. one sec.
Ground floor, baby.
Yeah, so in the chat now,
Hey,
in live
everybody.
stream chat. Oops, sorry. Live stream chat, the root mean square error for the globe is 1.3 arc minutes, and the error for the Celthio is 6.65 arc minutes.
Oh, wow. Okay.
That sounds like a big difference.
Yeah. So the closer that number is to 0, obviously, the better.
Yeah, so that, yep. I'm actually setting up to calculate the p-values for the celestial theodolite, the flat Earth celestial theodolite compared to the flat Earth prediction, and the globe celestial theodolite compared to the globe prediction, and show which one's got better p-values.
Yes.
You're gonna do
Jeremy,
a presentation?
which one of these measurements or peaks has the most?
Oh yeah, yeah. I was going to do a quickie presentation. It's kind of a rerun of last week, so I won't take too long at it. If anyone has
Pink
questions.
Floyd was trying to ask something, I cut him off. Sorry.
Okay, this is from last week, but it's titled "Globers Examine a Tale of Two Celestial Theodolites." And Gio was so petty. I asked him permission to do the follow-up after last Monday's Cell Theo thing, and he eventually did give me permission, but he told me to not call it he suggested that I not call it a Prezi because that was Alan's special word. So I called it not a Prezi. So the basic life cycle of the celestial theodolite is it originally started out and they tested it against Pike's Peak, which was was pretty close to the flat Earth prediction, so they were happy. Then they measured some more peaks and they kind of had some more error, but they were still closer to flat Earth than to globe Earth, so they were okay. Then some more peaks were measured that were undeniably closer to the globe, so they didn't know what to do at first. Heffron initially put in all these per occlusion fudge factors, but Alan didn't like that, and they kind of had a falling apart, and I think they kind of pushed Heffron out of the picture now, because he hardly ever shows up, and they don't use his corrections. Alan made his own spreadsheet. So Alan then invented a new celestial theodolite method, which was like the old one, but instead of putting stellarium on the peak, they put it at the observer location, but still with atmosphere turned off. And so in his own spreadsheets, when he says, well, it's closer to flat Earth.
I wasn't aware of that.
Oh, yeah,
They're
I
now
know.
not putting the observer?
Yeah, well, for only to compare to the globe prediction. They still use at the peak to compare to the flat Earth prediction, because that sometimes matches, but he didn't like the fact that sometimes that also matched the globe, so he then came up with a second celestial theodolite that would never match the globe because it had astronomic refraction turned off and it was at the observer location. And so that's how
so he's halfway there.
So that's how he could say, well, it never matches the globe closer. He was comparing it to something else that he had engineered to never match the globe, even if Earth was a globe. So that's when he says that the celestial theodolite matches flat Earth closer every time. It's not the celestial theodolite. There's two of them, but he's not telling anybody. So here's a clip of him saying that. Tell me if the audio comes through. Are you hearing audio?
Yeah.
Yes.
Oh, good. Did you hear that? He said the flat Earth was closer than what the globe predicts every single time. The problem is, he was using something else to compare the globe prediction to, something that would never match the observation, even on a globe, because he kept astronomic refraction turned off. The ironic thing is, if Earth was flat, and his theory of light intersection being straight was true, it wouldn't matter whether you put the observer on the peak or at the observer location, because it would be the same angle. A straight line on a flat Earth has the same slope at all points. So that's kind of funny. Anyway, what's ironic though is one little set of cells that he did put on his spreadsheet. You can see it right here where I have these red arrows put in. He actually is showing the error between the prediction and the observation for globe and flat, but he is actually representing globe more or less by at least including astronomic refraction, but not terrestrial refraction, but that gets pretty close. And so in all but one case, actually, this lower, you might not be able to read it, but it's 7 seconds for the globe, for the globe with astronomic refraction applied, and then up here is 11 seconds for the flat Earth without refraction applied. So he actually has a cell that reasonably does represent the globe error. He didn't tell anybody about this, really. But in all but one case, in this pair of cells, actually the globe is closer. So it's really funny that he was saying that the flat Earth was closer every time, when on the screen, while he was saying it, the globe was closer on the timing. So that was funny. And so, of course, the problem is he denies that refraction would change the occlusion time. This just illustrates that refraction would change the occlusion time.
Hang on.
And position.
I'm pretty sure he has agreed that it would.
Well, but he still claims, I mean, he's like double-sided about it. He tells all his followers that because the light is blocked, there's no refraction, and that the geometric angles to the mountain and the star are equal at the time that the occlusion is observed.
But he'll say that the refraction before it occludes can change the occlusion time. What's
that? Does he agree to that now?
I think so.
You might double check with him, because the whole thing isn't going to work. You know, if the refraction changes the occlusion time to where the star is no longer geometrically in line with the mountain, then the whole method fails, right?
I think it fails for many, many, many reasons, but yeah.
Anyway, this is, as far as I know, his understanding that as soon as the straight line is clipped by the mountain, that somehow the light up here magically quits going, and that's when the occlusion is observed. But you guys might want to check with him on that, since he won't talk with me.
Yeah, go back to the one previous.
What's that?
Go back one.
Okay.
Yeah, that one. It's like, if that orange line is when the occlusion happens, then, what happens to that red path?
Right. In fact, I heard that he threw Goose's refraction demonstration under the bus, saying it was a bad demonstration, because he did that demonstration in his garage with the little refractive thing and stuff, and showed that the refraction would change the occlusion time and angle.
Yeah. Yeah,
First
Goose is
time
a
I
tricky
talked-
one. What we go?
The first time I talked to Alan about this diagram you were showing, as far as I understood, he was saying that once the orange line gets intersected by the peak, you no longer see the star, which would mean the star would like disappear with a gap, right? Between before it reaches visually hits the peak.
Yeah.
His argument was that if the light is obstructed, then there is no refraction.
Hey, coffee. So, anyway.
Talking about in here, what's going on?
Hey,
Hey,
traditional.
Mongoose.
What
We're
up?
doing flat Earth measuring stuff. How are you?
I'm doing great. The hell are you guys measuring?
The curvature of Earth using the flat earthers' techniques.
Yeah, that'll definitely yield the best results, of course. Continue.
Hey, Coffee, I missed you. Hey.
Okay, so of course the glober's position is that the path of light is curved, and the moment of occlusion will be observed when the star is far enough below the mountain peak, geometrically, that the peak of the mountain will clip into that curved line of sight. And at that moment, the straight line geometric angle to the mountain will be represented by this upper orange line, and the physical geometric angle to the star will be represented by the lower orange line, which is why the true globe version of the celestial theodolite would add the astronomic refraction and subtract the terrestrial refraction, because that makes the difference between the physical angles of each of them. So that since we start with the physical angle of the star, then we add astronomic and subtract terrestrial, and that gives us the physical angle to the peak.
Word.
And there's some messy writing I put on there, which I probably shouldn't have, but I did. And I guess I went over this one. Oh, this is a big question that we all should be asking, though. Anyone that is allowed to ask questions during the Q&A should be asking this. They keep brushing me aside. The fact is, when you place stellarium at this exact date and time, if you put it at the observer location, you get 2 degrees 5 minutes and a half. If you put it at the mountain peak location, as they do, you get 2 degrees and a half, or almost 2 degrees and 33 arc seconds, or arc minutes. So if Earth were flat, those should be both the same angles. So this is a big question that they need to answer, and they keep avoiding.
Exercises in futility.
Well, that is true, but
It's
But-
already difficult. It's
but-
already difficult to make them admit refraction exists. So to make them incorporate it in calculation, it's another task.
Yeah, what homeboy said. Nico. Yeah.
okay, so here I took Alan's spreadsheet, and I wanted
Man,
to
you're
get
doing all this work just to be like, yo, you guys are wrong. And then they're just going to be like, no, you're wrong. And then that's just where the conversation ends.
well,
That's
but there's
pretty much it,
onlookers.
isn't it?
It's a battle for the onlookers. Go ahead, Bacon.
Oh, I think he summarized it well, actually.
He what?
He summarized it well, actually.
Oh, yeah. So I took Alan's spreadsheet because I wanted to see, well, because he uses his straw man globe celestial theodolite version to compare the globe to, and that's where he gets this large error of 121 meters when the flat earth error was 82. Somehow he gets 121, and that's because he uses a different version of the celestial theodolite to compare to the globe prediction. So down here in this table, I compared all of the data points to both the globe prediction and the flat earth prediction using the original celestial theodolite method with the observer on the mountain peak. And as you can see, these are the meters of error between the prediction it's closer to. So half of them were closer to globe, the other half closer to flat. The average error for the globe set was 30 meters, and the average error for the flat set was 116 meters. So when he says that they all match the globe closer, or match flat earth closer, he is not being honest. So then I wanted to know, well, what if we didn't strawman the globe and we used the correct method for the globe, including astronomic and terrestrial refraction, as I described earlier with the colored chart. And here you can see all the data points except one match the globe prediction closer. One of them is 4 meters closer to the flat Earth prediction, but that's just because the two values were very similar and random noise caused it to be slightly closer on Green Mountain, because that one was like right between flat and globe and not too far from either. And then I'm almost through this, and then we can open it up. Or if anyone has questions, just ask. This is very informal.
I have a question.
Uh-huh.
On your previous, like when we see all the result were green, you put an average of the error. But did you factorize the distance of the observation with the error? Meaning that if you take a closer observation, you will be more accurate. If you take a longer observation, you will be less accurate. You will have better.
The errors should be in angle, right?
I couldn't figure out what you said there, Nico. I'm sorry.
He's saying the errors, rather than being in meters, should be in angle.
Oh, I agree. And originally I was doing it that way, but Alan was like, "Oh, you shouldn't be doing it in angles. You should do it in errors. That's what really matters." There's a record of him saying that to me on the live stream back when he used to let me into the Q&A. So I just did it in meters because a lot of flat earthers don't understand angles. They actually don't, but they kind of understand meters. So that's what I do, and that's why. Although the angles are over here. So
Yeah, but if you want to put it in meter, if you have an observation with at 25 kilometer and another one at 50 kilometer, as you say, as Rui said, that the angle will be the same error of it. But if you just ponder after all these error by the distance, you will still have it in meter, but the error will be Ah, merde! Why you make me doing math at lunch? Oh.
Well, here, look at this. This one I did back before they cracked down on me for using angles, and I did it in angles, so this is arc minutes in the vertical axis here. The red line shows the globe, the error between the true globe Earth celestial theodolite method and the observations, and the blue shows the error between the flat Earth method and observation. So you can see that the globe does predict their results. Arctangent of rise over run does not predict their results.
Okay. But if you do the same graph that you have, you just have before, but instead of plotting each location as a unit, plotting the error function of the distance.
Okay.
It will show normally your result should be on a line that show on the same accuracy of result. It will show on a line, and it show better that which method is more accurate. Your graph is the missing scale of result. That's what bugged me.
It's missing scale?
Yes. Your previous graph. Come back of angle error previous graph.
This one?
This one. Yes. On horizontal line, I can see that you have a Pikes Peak, and that is the furthest away location they have.
Oh, I
Or
see. You wanted it sorted by distance. Okay.
by distance.
Um,
And
that would have not looked as good because of the different distances between them.
it should not change many things for the globe. That the globe will still whatever you do, it will still make a kind of a fat line.
I think
But
Rude did some stuff on the
for the flatter sir, it will point out at which distance their method is not consistent. 1 o'clock.
Oh, wow. 9 o'clock for me.
Is that a church? Oh, wait, that's China, so I think not likely.
Sorry
I have a
for that.
question. I have a question. Is it more like it's not really related, so you can come back to it later if you want. But I posted this image, which I think we've all seen, posted in the live stream chat. So it's just of the personal dome of vision. This is kind of the extreme case at the South Pole, Southish Pole. So what I couldn't gather, and I'm curious if anybody's like probed him on this, is like this is a really bendy light path, and in this case, the actual like the observer is standing at the end of that pink line, and they're looking out towards this yellow circle. Sorry, I'm you can't see my mouse, but you can sort of imagine it. So now the idea is that this could occlude for this person, right? But if there's a mountain in that yellow path, but
I'm
the yellow
sorry,
path.
I missed the end of that. You said that's the South Pole and what?
So I'm looking. Do you see the the image I posted? Did you see it? It's in the live stream chat. Anyway, sorry, I'm
I can,
rambling.
yes.
But my question is just like how, because the whole point is that like refraction, like when something occludes, the refraction's gone. But how do they has anybody probed them on like how they deal with this personal dome curving of light? Because it's almost like they just pretend like it's not there, and they call it like a true angle.
It's the gradical.
It's the gradical, bro.
And I think with the eclipse, this is where it's really gonna break down, because you actually have longer distances where you're gonna be able to see the sun and moon way further away. And when I was pushing on it, tonight they started to say that like, oh, it's all apparent. And so I'm just curious, like, if anybody's pushed on them, like, well, okay, if light's bending for the personal dome of vision, how can you justify that the occlusion makes a straight line?
They make it as vague as possible, so they won't even agree that there's a position where the star is and the light's bending from the star to the observer in that way. It's just a mix of various different things. Like it's a mix of perspective with curved visual space with whatever else you want to throw in the mix. There is no actual, there is no internal model in their heads of how this is happening.
That's kind of what I
There
felt
is
like. I felt like
no
they just go into
unified flat Earth theory. There is no unified flat Earth theory.
Doesn't even have to be unified. I mean, if one person had a consistent explanation for why we see stars in the position we see, that would be the first time this happens ever. That doesn't, not even that exists.
Well, shall I wrap up this little nota presi?
Oh, sorry.
Oh, that's okay. So these are 5 big questions that everybody should be asking Alan. Number 1 is interesting because The question is, would the original celestial theodolite method with the atmosphere off at the peak of the mountain also work on a globe? And Piezo admitted or stated today that it would not in the after hashing there, the after fights. So we need to find out if that's official from Alan or if that was just him winging it. Because if it doesn't work on a globe, then you can't use something that wouldn't work, that assumes flat to prove flat, right? That you need something that can measure that mountain regardless of flat or globe, so we can see if that mountain is dropped down like the globe predicts or not. So, and the fact that they provided a different method for comparing to the globe kind of suggests they know that theirs does assume a flat Earth and therefore wouldn't work if Earth was a globe. And in which case we need them to answer whether or not it would be possible for their original method to give flat Earth results even if Earth was a globe. And of course we know it could because of the way it works, which is how both their guys and I were able to get globe results using their method. And something else is falsifiability. They're always saying, well, is something falsifiable? Is this falsifiable? I have asked them many times, what is the criteria to falsify this? And they never can actually give any criteria for falsification because, well, they just don't know it. Dr. Heffron said that he tried to refute his hypothesis and was unable to. But then I asked him, well, what's the criteria for refuting it? And he couldn't tell me, and neither can Alan. So if there's no defined way to refute it, well, that's why he couldn't refute it. And then one last question is, if the celestial theodolite gives such terribly awful results, why are they still using it? So I'm going to paste this in the chat.
Well, they're going to say that they're still using it because they say it shows better results than the globe, yeah?
Right, but still, it's huge. It makes out, using that method, they measure Greenhorn Mountain or North Peak to be between 1,800 and 2,200 feet taller than it is. And they also measure Blinn Mountain to be globe size or smaller than globe, half globe size. So those
But they don't admit that, right? They don't admit that. They say that it's closer.
They recognize that it matches according to their original method, but they switch to a different celestial theodolite to compare to the globe. That's how they can say it's closer to flat Earth, because they're strawmanning the globe. They compare it to a different celestial theodolite method.
Okay, so if you ask them that question, right, what are they going to tell you? How are they going to answer that?
I don't know. They just mute me. So I honestly don't know. They don't want to answer. It's like I could say, hey, how come it gives an error of 1,800 feet? And they say, well, it's still closer to flat Earth than it is to this other globe version of celestial theodolite. But that doesn't remove the fact that it's still got an error of 1,800 feet on a flat Earth by their method. So it's still a huge error, and they don't want to address that. And so that's why we need to ask them to address that. An error is still an error, regardless of whatever anything else is closer to.
Yeah, no, I get that. And I'm not arguing that point. It's just that, like, when you run across somebody who has something particular in their mind and they're going to fight you on it and whatnot, sometimes I wonder if just repeating that over and over is a good way to go, or if you know what their answer is going to be, if maybe you should skip it for a while. But you're saying they've just never answered it?
They've not answered it when I asked it or when I was listening.
Okay.
It's like, their method gives this huge whopping error, and that needs to be, and it's far outside of their own figures for the margin of uncertainty, because they actually calculated, you know, the timing could be off a second, the observer elevation might be off a few meters, the target elevation might be off a few meters, you know, and they actually did some calculations to figure what is the expected plus or minus margin of error, and it was, you know, 100 feet or something, a couple hundred feet, not 1,800. So it's outside of their own calculated reasonable margin of uncertainty.
Do you think maybe it would be easier to get an answer from them if you spoke to them personally and not on a recorded VC?
I don't know. Alan used to talk with me in DMs. And one point he's like, I'm blocking you. All of our interaction from now has to be in the public recorded VC. And then he quit doing even that. So it's hard to say. I'd be glad to.
And I get that, but I'm wondering if he trusts me
Oh, you. Yes.
because I don't. No, like that's just part of the point. Like in general, people do trust me because I don't screw around with people. If he trusts me and I offer him a one-on-one, you offer him a one-on-one VC here in this server with nobody else that's not going to be recorded, I wonder if he would speak openly that way. Because if he DMs, you can screen cap it. If he speaks in a main VC, it's recorded. So, like, just like us being recorded for this,
Right.
there's going to be things that I'm going to be careful of saying because I don't want people to take it the wrong way or something, you know?
Yeah, you might try ask him. I'm game for sure. I don't think he would talk to me. I'm totally willing to. He might be more willing to talk to you about it.
I would have to be open with him though and say that these are your questions.
Totally. And that's legitimate. People say, hey, this Jesse guy, he said this, you know, and these numbers are in the spreadsheet. What gives? Is this cell not the error? Like, here's his spreadsheet.
It should probably not be me though, because I don't know if I am capable of asking the questions and
Yeah.
knowing what he's saying to me. But
Well,
somebody, we should find somebody.
maybe Bacon or
Bacon did a good job. I thought
Think-
Bacon did a good job tonight.
let's see here.
I think I
I
just
feel like
read
he's
your-
really good. He's really good at like just dragging you instantly away from the
Yeah.
point. Like as soon as you put your finger on one of the things that's broken, he's like auto scripts back into like, well, look in the spreadsheet, and he had like this routine tonight where he would just constantly go back to it, and like
Yep. Well, like this cell right here, H6, that is the error between the flat Earth prediction and the celestial theodolite. So all one would have to say, you know, is that the error in meters? And what causes it? That's a huge error. That's it's like 1,795 feet. 1,800 feet almost.
So Jesse, I'm with Coco in that I think if you're trying to play to the kind of the room, people like flat earthers listening to it will all they'll hear is that, oh, it's closer than the globe. I don't think they would care that it's like way off if they feel like it's closer. I could be wrong, but
Yeah, but I think some of them could still understand that a huge error is still a huge error. Like, you know, the whole closer thing is as a fallacy. You know, like let's say I says I'm going to guess your age. It's between 1,000 years and 1,000,000 years, but it's closer to 1,000 years, right? It is closer to 1,000 years than to 1,000,000 years. Did I guess your age closely though? No. It was closer, but it wasn't close at all. So
I'm not like I'm with you on it. I just like people, I think they just, I don't know. It's that, and then they have this thing where like if like when you come in, they just do a good job of like poisoning the well.
Yeah.
So it's like, well, Jesse, and like I think today I saw like, oh, Jesse just has his spreadsheet, but he just doesn't understand. He doesn't understand the method at all, so he's just done it wrong. That's kind of like the way that they hand wave it away. And then of course just like never talk to you again. I think you've seen it with like different people. As soon as they realize that somebody understands it, then they just begin like trashing the person and
Yeah.
preparing to like block and ignore them. I think Embo's like kind of right on the
But
edge of that.
But every now and again, one of them will challenge me directly later in the chat, and I'll engage them, and they'll engage, and it is slowly spreading distrust in the Celestial Theodolite. I think.
Yeah, that's good.
Anyway, this is some statistical stuff I did. I took their Pikes Peak measurement data, which was multiple occlusions collected across 2 different days or nights, and I put it into what do you call this? A histogram. And so you can see there was 4 samples that fell in this range, 8 in this range, and 5 in this range. And this is just degrees, actually. Interestingly, this red line represents the flat Earth predicted angle, and this was their standard distribution. So clearly, even though it was kind of close, it still was not a match. It was still outside of reasonable margin of uncertainty. And we saw that, and I'm just going to plug real quick, and then I'll be done. This is a spreadsheet I made actually for Taylor that lets you put in a temperature, pressure, humidity, and CO2 parameters for 2 different elevations along your line of sight, like say half a meter below and a half a meter above your line of sight, whatever. And it calculates based on the index of refraction that it calculates and the speed of light change or difference. It calculates what radius of curve the light would take in that case. And so it tells you how much refractive lift or sinking there would be based on the speed of light, based on the temperature, pressure, and humidity, completely independent of any globe assumption or anything like that. So with that, I relinquish the microphone.
Yeah, I think that's awesome, dude. Did you use this for the CT stuff?
No, I just used regular Seidelman's astronomic refraction formula. The same thing I think we used in the Desmos simulator. I used that also in the spreadsheet. Because I don't think that takes into account humidity, and Taylor was very interested in humidity, hoping that it would explain upward bending light, would predict upward bending light that would cause drop over distance and stuff on a flat Earth. So that's why I went to the extra effort to do it this way, to integrate the humidity as well. And the idea that 2 parts, 2 light rays of equal frequency that reach the target at the same time, an upper and a lower part of the same light ray, that's kind of geometrically simple for people, I think. I hope.
Yeah, I think so. I agree. It's nice. Well, dude, that's a lot of work put in. I think it's awesome. I love it, and I hope I didn't come across as disparaging. I do think a lot of times about just the mindset of people and how, like, in a lot of ways I think it's more a game of just like almost like psychology over accuracy.
Oh yeah.
It drives me absolutely crazy how much they just gaslight people on you personally and whatever. But the crazy thing is, I think that it's like it's a terrible technique, but I think it works. And you could hear like just. Did you tune in at all tonight?
I tuned in just like right at the end. I forgot about it, frankly.
It's just interesting hearing, you have them, they talk about it, but then when you hear anybody else try to articulate it, it's just funny because they're like nobody else in flat earth can even remotely explain it.
Yeah. Yep.
And I think partially that's, I mean, I don't know if that's the way they planned it, but that certainly is the way it.
I gave it a good shot to try to learn it. I knew I was going to have a hard time, me being me. But yeah, if they can't explain it well enough for someone like me who's really trying to learn and wants to learn, that's kind of an issue. But I don't want to say that to them because I don't want to seem rude.
They don't want anybody to actually understand it. That's the thing. It's actually a very simple principle. It's like, I bet I could explain it to you in 60 seconds. You time the occlusion of a star, you put the date and time in stellarium, place it at the peak of the mountain with atmosphere off, and you read the altitude angle of the star, and that is what they claim to be the true elevation angle to that mountain. That's literally all there is to their method. And
So, I'm sorry, go ahead.
well, that was about it. It might take a few more minutes to kind of go over things a few more times until it felt intuitive to you, but that is all there is to it.
And they have a graphic for it that is kind of that simple, I feel like. But then whenever they start talking about today, when Alan was just going through the presentation, it was like I've looked at the spreadsheet of like unpack the formulas, and as he's jumping around, I'm like, whoa, it's like I don't know. I wouldn't say he's necessarily doing it on purpose, but he really like I know Shane does it on purpose when he presents. It's like he just like tries to
Shane
overwhelm.
does.
He just absolutely just overwhelms with like as much information, and he just like goes through like slides like I always say that you can tell how nervous Shane is by how fast, like how many slides per minute he goes through. But but it's like you might think you understand it. My guess, Coco, is you got points where you're like, okay, this makes sense, and then you listen to him talk for 20 minutes and you're like, I'm not so sure I understand it.
Yeah, and
That's how I feel.
honestly, it's true though, because even if it's nonsense, right? If it's your world, you should be able to explain it. Like if I talked to one of you about The Hobbit, you would be able to explain that to me. Like if I said, oh, what's this in this chapter when they're talking about this, and it's your world, you're a fan of it, you should be able to explain it to me, right? And I should be able to understand it, whether it's a real thing or not. So none of that matters. And that's where beginning, like I was having an issue with, like, I never know if it's me being stupid. Like there's a lot of times people explain things to me and I have to ask questions until I get it, right? And I kept asking questions and I still don't understand it. And at that point, it doesn't matter if it's real or not. It matters that they're not explaining it correctly. And then you got to ask, why are they not explaining it correctly? Because I like Alan. I would let him explain anything to me. I'm still not understanding it, and that means there's something wrong.
Yep, agreed.
Yeah, and I don't think it's you
It's definitely not you.
at all.
Yeah, I'm at the point where I'm starting to think it's not me. You know, and like they did listen to some of my feedback when I was telling them about the videos really not showing, like, the stupid knife in the cup video. I don't even know the point of that. None of that made sense. And they did redo that other video. So they're trying. I think they're trying. But yeah, there's some disconnect somewhere.
Who would you say, like, anybody in, like, that's in the flat Earth community that's not like one of their whatever followers, I guess? Like, who do you think understands it?
This celestial theodolite thing?
Yeah, yeah. Who do you think understands it the best in the flat Earth world?
Oh God, I have no idea. Because I don't talk to anybody really outside of Alan about it.
Yeah, that's probably true. It's sort of like there are these topics. I would say like the personal dome of vision is another one where it's like really, really fundamental to all the stuff that they do, but nobody will talk about it and nobody can explain it and nobody likes to talk. Like I'll bring it up just because I know it makes people uncomfortable, and people just do not like engaging it.
You know who I miss? Who, if they were here, I would make them explain it to me. Cleary.
Oh, I haven't seen him around in a while.
Me either. I lost touch with him after the whole Riggs incident at Worldwide. There were a lot of people that stopped talking to me after that, but I heard he was going hard at telling people shit about me. So I have no idea at this point if he stopped talking to me because of that, or if he stopped just coming around at all.
No, I haven't seen him at Worldwide.
Okay. Then
Maybe
he might
maybe
just
occasionally.
be going through his own shit. And that's a shame. I hope he's okay because he's just so nice.
It looks like he last spoke on rig server 1030. So I guess that would be a month and a half ago. It's 12:15 now.
When did I last speak in there? Because Riggs was saying it's been 3 months. Doesn't seem like 3 months, but honestly, I haven't missed it at all.
I'm not sure how to search on someone who's not a member.
I think you just have to know their exact username, which we do.
Oh,
I don't
maybe
come
he's gonna
up.
try it. Hold on. Ooh,
Maybe.
I found it. 1016. Oh, the day before you. He hasn't. You spoke the day after he last spoke. You last spoke the day after
Okay.
he last spoke.
Yeah, see, 1016. So it's only been 2 months. He's telling Don it's been 3 months. And I was only banned for a day, he says, and it was weeks. It was like 2 or 3 weeks that something happened and I tried to get back in for an event and couldn't get back in. So I've been banned this whole time. Hey, Bo.
Good evening.
Oh, he lasted 2 weeks after you were gone. Clary. Hey, Bull Knight, how's it going?
Pretty good.
We are live, but I suppose we're about done, so I could stop the stream, I reckon.
You
Unless you-
sure can.
Unless Bull Knight wanted to talk about Celestial Theodolite.
We could talk about saddaloons. We could talk about your tree.
Ooh, saddaloons are nice. I did ask. I was talking to Geo 10 minutes ago or so. Talking about hypothesizing what would happen if, let's say, there was person A doing the old silly Theo observation, and then somebody was half the distance between them and the mountain peak doing the same silly Theo observation of the same star, and what that would output. And I would hypothesize that it would make the true shape of this realm a little more apparent than the current silly Theo manages to.
Yeah. Well, how did he react to that?
He thought that was a great idea and wondered if anybody talked about trying it. Now, obviously, it takes coordinating two people to do a observation, which is 5 times harder than doing it yourself. And I don't live near mountains, so I can talk all day long about what other people should do who do live near mountains.
See, I had an idea that was similar. I asked Jesse about it, and he thought it'd be too hard. But it's basically where you get it's very similar. Where you get 2 people. So the first person's looking at the peak, right? But then you get a third person that's back, but they're set up in such a way that the location of the middle observer occludes them. Does that make sense?
Like a stair step.
Yeah, but they're like they're theoretically sort of like in a straight line, right? And the idea is that if you set it up like that, you should get the same angle at each spot because it's it would basically be
Right.
like triangles. But of course, we know on a glow that would be physically impossible.
Yep.
So I thought of that as like it's a theoretical test that would be guaranteed to fail. But I don't know if you could find.
I think you'd get
practically
the
a
same
way to
result
do it.
with non-collinear, to borrow a phrase, observers that are in a line, like that's a straight line between A, B, and the mountain to peak. So the star, there would be the same kind of triangular relationship required for it to plane trig into a triangle.